Hi everyone, welcome to mathworld. This video is to show you the solution of Cambridge International AS and A-Level Further Mathematics Paper 4, which is the Further Probability and Statistics for May-June 2022, and the code is 9231/41 or 9231/42. Okay, so let's move on to question number 1. Now, question number 1. A manager is investigating the times taken by employees to complete a particular task as a result of the introduction of new technology. He claims that the mean time taken to complete the task is reduced by more than 0.4 minutes. He chooses a random sample of 10 employees, and the times taken in minutes before and after the introduction of new technology are recorded in the table. Okay, so now by looking at this table, you are getting the employees A to J. Okay, there are 10 employees here, and the corresponding time before the new technology and after the new technology. Okay, so now A. Test at 10% significance level whether the manager's claim is justified. Now, by looking at the question, we know that the manager's claim is the time taken is reduced by more than 0.4 minutes with the new technology. Alright, so now your H naught, the mu D, or I need to define what is my D first. Okay, so let me define my D first. Now, by looking at the claim here, it's mentioned that the time will reduce by 0.4 minutes, means I will expect the time before the new technology will be greater than the time after the new technology. So, right? So that means I will define my D as before minus after. Okay, so my D is basically time before new technology minus time after new technology. Right? So from here, to show that there is a reduction of more than 0.4 minutes, I will have to write it in the H1. So it will be mu D greater than 0.4. So now my H naught will be mu D equals to 0.4. Okay, now our next step is to write out the alpha value, which is 10%. So alpha equals to 0.1. Right? So from here, since we are using the D, we have defined the D, means that this is the paired data analysis. Then we need to find the differences, the DI. Okay, so now my DI will be counted using before minus after. So by looking at the table, okay, so before minus after the first value. So 10.2 minus 9.6 is basically 0.6. Alright, so 9.8 minus 8.5, it will be 1.3. So I will count up to the data number 10. Alright, so I will list down all the 10 values here. So now my DI will be 0.6, 1.3, then 0, 0.7, 0.6, 1.8, negative 0.2, negative 0.7. No, the next one is negative 0.2 as well. Okay, then followed by 0.4. Alright, so these are the 10 values or 10 differences that I have counted from the table. So you just keep minusing. Alright, so now from here, I need to calculate what is my summation DI. So now my summation DI will be 5.6. Means that you add up all the values. Alright, then the summation DI squared means this is 0.6 squared plus 1.3 squared plus until 0.4 squared. So this is how we count this value. Then it will be 6.74. Okay, so now your D bar it will be summation di over the n. So now we have 10, right? 10 data here. So it means that here n equals to 10. Then my d bar will be 5.6 over 10, which is 0.56. And then now we need to get SD squared. So SD squared formula is 1 over n minus 1 multiplied by summation di squared, then minus summation di, then you square it over n. Alright, so then this will be 1 over 9. Summation di squared will be 6.74. Then minus square of summation di, so square of 5.6, then over 10. And then the answer will be 0.4004. I will give more significant figures here because this is not the final answer yet. Alright, so from here, once you have counted all this, now basically you can just count the values first, but before I count what is my t value, I need to draw the graph. Okay, write down the rejection region first. So by looking at this H1, since this is greater than 0.4 means that this is upper tail test, which means now your critical region is on the right hand side. Here is 0.1. Alright, but then when you refer to the t-table, the t-table always shows you the result, the region towards the left hand side. That means I'm going to read this value as 0.99, t 0.99, and the degrees of freedom is n minus 1, which is 10 minus 1, and I will get 9. So now from the table, you need to refer to degrees of freedom 9, and the region, the alpha is 0.99. So from here, I will get 1.383. Okay, this is the value for this line, straight line. So now my critical region will be reject H0, or my rejection criteria. So I will write reject H0 if t is greater than 1.383. Okay, so now once you have found the SD, right? So now we need to count the t value. So our t is basically d bar minus mu d over SD over square root n. Okay, but then since we have counted the SD squared, here is our SD squared. So instead of writing SD over square root n, you can just write SD squared over square root of SD squared over n. Right? So I can change to this form. Okay, so now when I replace the values, my d bar is basically 0.56. Then my mu d is the value at the H0. So now at the H0, my mu d is 0.4. So here you minus 0.4, then over square root of SD squared that we have counted just now, 0.4004. So here 0.4004, then over the n is 10. Right, so when you calculate this value, it will be 0.7996. But then we always write our answer correct to 3 significant figures. So once I have rounded up this value, it becomes 0.800. Okay, so now you have to compare this t value with the critical value in the graph. Okay, so this t value is 0.800. So from here, I will mark it. So it is before the straight line, right? Because this straight line is 1.383. So since this is before and it is not in the shaded region, our decision is do not reject H0. Right? So now you may write down your decision here. Then you can write since t is less than 1.383, then you can say do not reject H0, or you can say accept H. This is t less than 1.383. Alright, so reject H0 when it is greater than. So here. So now we do not reject H0. So instead of writing do not reject H0, another option is accept H0. Right. So now I will write accept. So you have two choices. So you write accept H naught. So when accept H naught, that is your decision. Now the question is asking for whether the manager's claim is justified. Alright. So now since we accept H naught, the manager's claim is at the H1. So it means that there is insufficient evidence to support the manager's claim. Right, that is our conclusion of this hypothesis testing. So here I will write there is insufficient evidence at alpha equals to 0.1 to support manager's claim. Okay, so that's all for this solution. Okay, now B. State an assumption that is necessary for the test to be valid. Alright, so now the assumption is distribution of population differences is normal. Okay, it must be normal. Alright, so that's all for the question 1. Right, so now question 2. The probability generating function GYT of the random variable y is given by this quadratic equation. So A, find variance y. So the variance y formula is gy double prime 1 plus gy prime 1 minus gy prime 1 squared. Okay, that is the formula for variance y. So the gy prime 1 means that the first derivative. Okay, gy double prime, that means that is the second derivative, which means now I need to differentiate the gyt. So now my gy prime t, so we are differentiating the gyt with respect to t. So first term is a constant, then you will get 0. Second term, we drop the t, it becomes 0.2. Okay, the third term, when you differentiate 0.37 t squared, it becomes positive 0.74 t. Okay, next term, when you differentiate 0.3 t cubed, it becomes plus 0.9 t squared. Then last term, 0.09 t degree 4, it becomes 0.36 t cubed. Okay, so now I will get my second derivative first before I calculate the gy prime and gy double y prime when the t equals to 1. So when you differentiate the gy prime now, the 0.2 becomes 0 because this is a constant. So the next term 0.74 t becomes 0.74. Okay, then the third term differentiate 0.9 t squared becomes plus 1.8 t, and then the last term here differentiate 0.36 t cubed becomes plus 1.08 t squared. Okay, so once I have found these two expressions, then I will replace the t values by 1. So now my gy prime 1 will be 0.2 plus 0.74 plus 0.9 plus 0.36. So at last, it will be 2.2. Okay, same goes to the gy double prime 1. So now refer to the second expression, the gy double prime t, and let the t be 1. So 0.74 plus 1.8 plus 1.08. Then this will be 3.62. Okay, so once we have found these two values, 2.2 and 3.62, then you can just substitute back into the formula. So now my variance y will be 3.62 plus 2.2 minus square of 2.2. Okay, so at last you will get 0.98. So that's the solution for A. Right. So now, the random variable y is a sum of two independent observations of the variable x. Now B, find the probability generating function of x. So now we need to find gxt, giving your answer as a polynomial in t. Alright, so now y is the sum of two x. Right, both x are independent variables. So from here, your y is x plus x, or x1 plus x2. Right, but both of them are the same. Okay, so from here, I will write gyt. When it is a summation here, your gyt is basically multiplication. So gxt times another gxt, because both x are the same, right? So now, I will say that this is basically square of gxt. Alright, so now, by looking at the gyt just now, your gyt is a quadratic equation, t degree 4. So in order to get t degree 4 after you square a polynomial, right? So it's understood that the polynomial must be a quadratic. Otherwise, you won't get quadratic once you square the function. Okay? So from here, I will say let gxt be a quadratic function. Right? So the reason is once you square the quadratic, you will get quadratic equation. So now I will say that my gyt, so now I have to rewrite my whole gyt from the question. So 0.04 plus 0.2t, then 0.3t, 37t squared, 0.3, 0.09t4. Okay, so 0.37 t squared plus 0.3 t cubed plus 0.09 t degree 4. All these are the terms of my gyt. Okay, based on here, then it will be equals to square of quadratic. Right, so I will write at square plus, or probably I will just write here, equals to at square plus bt plus c squared. Okay, so now when I need to do expansion for these three terms, right, I will group them into two terms. So I let this be the first term, at squared, and the bt plus c as the second term. So then I will use a formula, a plus b squared equals to a squared plus 2ab plus b squared. Another option is you can just rewrite the bracket and then you do the expansion one by one. Alright, so now I'm going to use this quadratic formula to solve the problem. So now what I need to do here is I will write this equals to at squared. Okay, or I will do it separately because I need more space for this. So I will just write at squared plus bt plus c squared. Then it will be, right? So let this be first term, bt plus c as the second term. So it will be square of at squared, which is our a squared over here, plus 2 of first term times the second term. Then plus third term squared. Alright, so now further expand all these terms. So I will get a squared t degree 4 plus these two at squared will combine together and multiply by bt. So I will get 2abt cubed. Okay, and then this multiply by c. So I will get plus 2act squared. And then for the last bracket, I will apply the quadratic formula again, right? So now you will get b squared t squared plus 2bct plus c squared. Okay, this is what I get. Now from here I can simplify, right? So it will be a square t degree 4. I will group the same terms. The same terms means that with t with same degree. Okay, so the second term I will rewrite, and then the third term and fourth term will be combined. So here plus t squared, then 2ac plus b squared. Then after that, followed by 2bct, then plus c squared. So the c squared is basically our constant here. Okay, so now I'm going to compare, right? So I will compare with all these terms, right? So now, if you want to rewrite 0.04 plus 0.2t plus 0.37t squared plus 0.3t cubed plus 0.09 t degree 4 equals to all these terms. So I will just rewrite a square t4 plus 2ab t cubed plus t squared bracket 2ac plus b squared, then plus 2bct plus c squared, right? So now remember we need to find gxt. Gxt is the quadratic, means that now we need to find abc. Okay, so now by comparing the coefficients of t degree 4, right? So when I compare the term with, or the coefficient of t degree 4, so now a squared equals to 0.09. Which means my a is going to be square root of 0.09, then you will get 0.3. Okay, so now next I will compare with t cubed. So when I compare with t cubed, as you can see from here, right, this is a t cubed. So which means 2ab equals to 0.3. And we have found the a just now. So now I will write 2 bracket 0.3b equals to 0.3. Then the 0.3 can be cancelled off from both sides. Therefore, my b is basically half. Okay? So now next, next is to compare the t. Okay, because now we need to find the c. A, B, C. Okay, or the easiest way is just compare directly the constant to find the c. Right? So now here, I will just write constant. So c squared equals to 0.04, which means my c is going to be 0.2. Okay, so from here, our gxt is going to be at squared. If you remember, this is at squared plus bt plus c. So now my a is 0.3, so I will get 0.3 t squared. My b is half, you can write 0.5. So plus 0.5 t, then plus c. c is 0.2. So that is the probability generating function of x. Right? Now question 3. The continuous random variable x has probability density function f given by fx equals to kx multiplied by 4 minus x when the x defined from 0 to 2 inclusive 0, and when the x between 2 and 6 inclusive both, then your fx has been changed to k times 6 minus x. For other x values, the fx is not defined. That's why it equals to 0. Now where k is a constant. So for a, we need to show that the k equals to 3 over 40. Okay, so we need to apply the theorem that the total probabilities will be 1. Okay, probabilities is counted using integration. So from here, I will integrate the first function from 0 to 2 plus the second function, integrate the second function from 2 to 6 and let it be 1. So at the same time, since your k is a constant, I will factorize a k when I do my integration. So here 0 to 2, then x bracket 4 minus x dx plus the second function also contains k. So I will factorize the k as well. Then from 2 to 6, the limits, then 6 minus x dx. And it will be 1. Okay, so from here we need to do integration. Alright, so now I will write k. When you do expansion, this is 4x squared. Sorry, 4x. This is 4x. Then here will be x squared dx plus k integrate 2 to 6, then 6 minus x dx equals to 1. Okay, so from here, we will start doing the integration. So when you integrate 4x with respect to x, it will be 4x squared over 2. Then I will just write 2x squared. Okay, the second term will be x cubed over 3, limits 0 to 2, plus another function is integrate 6 minus x, it will be 6 minus x squared over negative 2. Okay, then 2 to 6. Or you may integrate term by term. So now from here, you replace the x by 2 first. Alright, so replace the x by 2, then followed by 0. So now I will get k bracket 2 squared is 4, minus 2 cubed is 8. Then when the x goes to 0, you will get 0. Then plus k. So now when you replace the x by 6, right? So 6 minus 6 is 0. So I will get first term 0. Then you minus the function, right? So now your function is negative. So minus minus becomes plus. Then now when you replace the x by 2 here, 6 minus 2 is 4. 4 squared becomes 16. So I will write 16 over 2 equals to 1. So now when you count the first, it will be the first term, it will be 16 over 3. So from here, I will just continue. So 16 over 3k, then plus the next bracket, it will be 8. Right, so 8k equals to 1. So 16 over 3k plus 8k, it will be 40 over 3k equals to 1. Therefore, our k is 3 over 40. Okay, so this is how we show the k value. Alright, so now B, given EX is 2.5. The EX here is expected value. So now we need to find the variance X. So for your information, variance X is EX squared minus square of expected value. Okay, this is the formula for variance X. So now what we need to do here is you need to count what is your expected X squared. So now our expected X squared is integrate the function, okay, this function, but multiply by X squared because of EX squared for the given domain. Right? So now since the k is constant, I will just factorize this k. And at the same time, I will replace the k value by 3 over 40, which means I will write 3 over 40 integrate. Now, as I have mentioned just now, EX squared means you have to multiply the x squared, this x squared, to the existing function. This is the function. So from the previous calculation, I know that my first function, it is 4x minus x squared. So once you have multiplied each of these two terms, each of the terms by x squared, so first term instead of 4x now becomes 4x cubed. Then the second term instead of x squared, it becomes x degree 4. So I will write down the new terms. So I will write 4x cubed minus x degree 4 dx. Limits will be from 0 to 2. Okay, then plus, same goes to the second function. So now my second function is straightforward. K integrate 6 minus x dx. So that is my second integration. I will replace the k value by 3 over 40. At the same time, each of these 6 and minus x will be multiplied by x squared. So I will get 6x squared minus x degree 3 dx. Alright, so now here I need to integrate term by term. So 3 over 40. The 3 over 40 I will factorize from both integrations because they are common, right? So then put a bracket. So when I integrate 4x cubed, I will get 4x degree 4 over 4, which is x degree 4. Then minus x degree 4 becomes x degree 5 over 5. The limits will be from 0 to 2. And then plus 6x squared, when you integrate, it becomes 6x cubed over 3. Alright, that means it becomes 2x squared. Sorry, it becomes 2x cubed. Right? The x degree 3 becomes x degree 4 over 4. So limits 2 to 6. Okay, so now once you have integrated both functions, so now we need to replace the x values by 2 and 0 for the first function, and the second function will be by 6 and 2. So I will get 3 over 40 multiplied by 2 to the power of 4 is 16. Then 2 to the power of 5 is 32. So 32 over 5 minus when the x goes to 0. So both will be 0. Okay, plus. So now when I replace the x by 6 here, right? 2 times 6 cubed, it will be 432. Minus, when I replace the x by 6, it will be 6 degree 4 over 4. So you will get 324. Right? And minus, when the x is replaced by 2. So 2 cubed is 8. 8 times 2, 16. Minus 2 degree 4, right? 2 degree 4 is 16, so 16 over 4, you will get 4. Okay, so from here, you will get 7.92. That is our EX squared. And now the question is asking for variance x. So now you need to substitute into the variance formula. Therefore, variance x is 7.92 minus square of 2.5. Alright, so at last you will be getting 1.67. So that's the solution for part B. Okay, so now C, find the median value of x. So we know that when you integrate from A to median value, right, let's say the m is median, then the probability, this value will be 0.5. Okay, or the integration is actually representing the probability. So now we need to find out what is the median value. So but then there is one challenging part here, which is you are given 2 intervals, right? So we are not sure where is the median, whether it's in the first interval or in the second interval. Therefore, I will suggest, right, to calculate the integration for the first interval, and we need to find out what is the total probabilities first. So if the total probabilities here means that the integration from 0 to 2 for this function, it is greater than 0.5, means that your median lies between 0 and 2. Okay, otherwise it will be in the next interval. Okay, so let's start with the first integration. So now I need to integrate 0 to 2. The function is kx times 4 minus x. So again, replace a k by 3 over 40. So I'll factorize the k, then x bracket 4 minus x. Okay, I need to count what is this probability first. So it will be 3 over 40. Then here becomes 4x minus x squared dx from 0 to 2. And then here will be 3 over 40. So let's check. The integration already found just now, basically. Okay, it's here. Right? So I will just jump the steps from here. Or probably I just copy back these two steps. So 2x squared minus x cubed over 3, 0 to 2. Then now here, 3 over 40. Right? So no need to redo the calculations, just copy from previous. So which is here. 2 times 4 minus 8 over 3. Then minus 0. Right? So when you count this value, it is basically 0.4. So when 0.4 means that it is less than 0.5. So now I will interpret this as the median does not lie in this interval 0 to 2. So it will lie, the median lies between 2 and 6. Okay, it will be in the next interval. Alright, so at the same time I will define my median as m because I need to do the integration. So let median equals to m. So now your second integration, the limits, right, or the interval start with 2 until 6. So now we need to integrate from 2 to m so that the probability will be another 0.1. Okay, because we know that from 2 to 6, let's say here 2 to 6, 0 to 2. Okay, the probability here is 0.4. Then from 2 to 6, right, definitely is 0.6. So that the total probability is 1. So now we need median. Let's say here is a m. Then median means that from beginning until median should be 0.5. Or on other words, from 2 to m, it will be 0.1. That's the probabilities. Right? So now, from here, I will write from 2 to m, the second function. So when you integrate second function, so I will just copy this, 6 minus x, together with the k value, 3 over 40, 6 minus x, dx, it will be 0.1. Okay, as shown in this diagram. So now, 3 over 40, where I integrate, or I can just direct copy the solution. For the integration, it will be 6 minus x squared over negative 2. So, and limits 2 to m equals to 0.1. So now, the working becomes simple. Just replace the x by m. Okay, so and at the same time, right, so I can just simplify all these terms. See here, this, and together with the negative 2 at the bottom, I will just move all these terms to the right side. Okay, then I do not need to bother the fraction anymore. So I will get 6 minus m squared minus 6 minus 2 squared, because my x is 2, so it becomes 4 squared. That equals to all these terms, you move to the right side, it becomes negative 8 over 3. Okay, so now to get the m, I can just move this negative 16, the 4 squared, to the right side. So you will be getting square of 6 minus m equals to 40 over 3. Right? So then from here, 6 minus m will be plus minus square root 40 over 3. So our square root 40 over 3 will be plus minus 3.65. Okay, so now I will write 6 minus m is 3.65, or 6 minus m is negative 3.65. Now I need to get the m. Since this is minus m here, this minus m will be moved to the other side. So now my m will be 6 minus 3.65, and you will get 2.35. The other one, this m moved to the right side, and the negative 3.65 moved to the other side. It becomes plus. So now my m is 6 plus 3.65, which means this is 9.65. But then we cannot accept both values, because when you refer to the question here, this function k times 6 minus x is only defined from 2 to 6. Alright, means that your x cannot exceed 6, cannot be more than 6. So therefore, this m must be ignored, or you just write not possible. Okay, so your final answer, the m, the median, is going to be 2.35. Alright, so we have done this question. So now let's move on to the next question. Next question. A scientist is investigating the numbers of a particular type of butterfly in a certain region. He claims with the numbers of these butterflies found per square meter can be modeled by a Poisson distribution with mean 2.5. He takes a random sample of 120 areas, each of 1 square meter. Okay, it's the same. You see here, per square meter, this is also 1 square meter, and counts the number of butterflies in each of these areas. The following table shows the observed frequencies together with some of the expected frequencies using the scientist's Poisson distribution. Okay, so now from here you have two unknowns, P and Q, in the expected frequencies. So A, find the values of P and Q correct to 2 decimal places. So since the question says that it is Poisson distributed, right, and the mean is 2.5, so now I will write Px is Poisson, right? So then the P here is basically the expected frequencies. So expected frequencies is basically our probability multiplied by 120. Okay, so now, and this P happens when the x is 4. So I will write P is basically 120 times probability x equals to 4. Alright, so here 120. For your information, the Poisson distribution x is Poisson lambda. So your Px equals to small x, it will be e minus lambda power x over x factorial. Okay, so from here, you just write e power negative 2.5, then times by 2.5 to the power 4 over 4 factorial. Okay, so when you calculate this probability, it will be 120 times, the probability itself is 0.1336. So when we count this value, it will be 16.03. I give 2 decimal places because all of your expected frequencies are 2 decimal places. Okay, that's the P calculation. Now for the Q, this Q is the expected frequencies when the x is at least 7. So for Poisson distribution, your x value starting from 0 until infinity. So in order to get this Q, right, we may use 120 minus all of the rest of the expected frequencies. So that's the easiest way to count. So Q equals to 120 minus the total of the expected frequencies. So 9.85 plus 24.63 plus 30.78 plus 25.65. Then the P we have just counted 16.03 plus 8.02 plus 3.34. So when you count this value, it will be 1.7. Okay, so this is the solution for A. Now, B, carry out a goodness of fit test at 10% significance level to test the scientist's claim. Okay, so now the scientist's claim is basically Poisson distributed because he claims, right? So it will be the number of butterflies will be Poisson distributed with mean 2.5. That is the claim. So now our H naught, number of butterflies found per square meter. Just copy from the question. Is Poisson distributed? With mean 2.5. Okay, then our H1 is not, okay, Poisson distributed. So we have to rewrite the sentence. So it's not Poisson distributed. With mean 2.5. Right, so now alpha is 10%. So I will write alpha equals to 0.1. Okay, so now let's look at the table. So just now we have found the Q is 1.7. So here is 1.7. So now for the goodness of fit test, we need to use chi-squared test, alright? So from here, the expected frequencies should be at least 5. Otherwise, you need to combine the cell. So now, 3.34 and 1.7, these two we need to be combined together, right? So it means that I have to redraw this table. I have to copy this table before we do the calculation. Right? So when I redraw the table, let's say the number of butterflies will be X, then OI will be the observed frequencies. So you can just write observed frequencies here. OI. Then expected frequencies, I let it be EI. Okay, then now I need to copy all my values 0 to at least 6. Okay, so right here 0, 1, 2, 3, 4, 5, then at least 6. After combining two cells, then the OI just copy from the table 12, 20 until 0. Okay. And then the expected frequencies also copied from the table 9.85, 24.63, but then the last two must be combined. So when you combine, the last two will be 5.04. Okay, so when you add up these two values. So the last one is 5.04. Okay, so now after you have drawn this table, I will write down the critical region first, or critical value first, followed by the rejection criteria. So critical value, right? So when you look at the question, the H0 and also the H1, okay, I will say by looking at the H1, this is our table. Right, so now the H1 says is not Poisson distributed and the alpha is 0.1. Okay, so now for the critical value, since we are using the chi-square test, so just for information, right, here is going to be 0.1, and then here is the region before that will be 0.9. So your chi-squared value is basically chi-squared. Okay, now degrees of freedom is n minus 1. Now the n minus 1 is based on the latest table. So here you have 1 to at least 6, means that there are 6 together with the 0, it becomes 7 cells. Alright, so now it becomes 7 minus 1, then I will get 6. So this is 6, 0.9. Okay, so from the chi-square table, you will get 10.64. So this line is basically 10.64. Okay, and the region is on the right side. So from here, I will write reject H0 if the chi-squared is greater than 10.64. Okay, so now we need to do the calculation for the chi-squared based on the latest table. Alright, so now chi-squared is summation OI minus EI, you square the difference, then over EI. Right, so now the first pair is OI minus EI, so which means 12 minus 9.85, then you square this and divide by 9.85. Right, so this is how we count the chi-squared. So I will write 12 minus 9.85 squared over 9.85. This is from the first cell. So the second cell, still the same. So 20 minus 24.63, then you square it and over 24.63, right, until the end. Okay, so I will just write down the calculations here. Then the next cell, it will be 36 minus 30.78 squared over 30.78, then plus 32 minus 25.65 squared over 25.65, and then plus 13 minus 16.03 squared over 16.03 plus 6.8, 6 minus 0, 8.02 squared over 8.02, and lastly it will be 1 minus 5.04 squared over 5.04. Okay, so here you will get the total of 8.12. So means that the chi-square is 8.12. Right, so now by comparing with the critical criteria, or I mean the rejection criteria, so your chi-square is greater than 10.64, then you have to reject H0. So now your calculated value is only 8.12. So 8.12 is basically outside the region. Okay, so therefore we will accept H0. We cannot reject. So now you write, since chi-squared is less than 10.64, accept H naught. That is our decision. So when accept H naught, okay, go back to the question. To test you need to test the scientist claim. So the scientist claim, right? So now we are going to, because we accept the H naught, so we support the scientist claim. All right. So you write in proper way. So there is sufficient evidence, because the scientist claim is the H naught to support. So there is sufficient evidence to support the scientist claim. Right? So this is the goodness of fit test. Okay, next. Number 5. Rahman is researching the heights of male giraffes in a particular region. Rahman assumes that the heights of male giraffes in this region are normally distributed. He takes a random sample of 8 male giraffes from the region and measures the height in meters of each giraffe, and the heights are given. Okay, so A, find a 90% confidence interval for the population mean height of male giraffes in this region. So from here, right, so 90% confidence interval for population mean. Population mean is basically mu. Our formula is x bar plus minus. We are going to use a t-test here, because in the question, right, when you look at the question, first 2 sentences, you are given that they are normally distributed, but then the population variance is not given. And then one more important part is the random sample is only 8. It is less than 30. Alright, the n is only 8. So due to this reason, variance is not given. The n is small. Therefore, we have to use t. So the formula is t. Then here is going to be alpha over 2, then degrees of freedom, then s over square root n. Okay, so this is the confidence interval formula. But before we substitute into this formula, we need to count the x bar and the s. So now I need to get my summation x first. So now my summation x is the sum of all of these terms. Alright, so it will be 5.2 plus 5.8 plus 4.9 plus 6.1 plus 5.5 plus 5.9 plus 5.4 plus 5.6. So your summation x is basically 44.4. Okay, then the next calculation is summation x squared, which is you square each of these. Right? So 5.2 squared plus 5.8 squared plus 4.9 squared plus 6.1 squared plus 5.5 squared plus 5.9 squared plus 5.4 squared plus 5.6 squared. Then at last you will be getting 247.48. Okay, so from here I will get my x bar. My x bar is basically summation x over n, and it's mentioned that there are 8 male giraffes heights, so it means that your n is 8. So now I will get 44.4 over 8. Okay, so then you will be getting 5.55. Then the s square is going to be 1 over n minus 1 multiplied by summation x squared minus square of summation x over n. So here at last you will get 1 over 7. Summation x squared is 247.8. Then minus square of 44.4. Then over 8. Alright, this value is going to be 0.151429. So I give more decimal places here because this is the working. Alright, so now substitute back into the formula. Your x bar is 5.55 plus minus the t value. Right, so now let's look at the t graph. So this is our T graph, and then we are finding the 90% confidence interval for mu. That means the region in between is 90%. Okay, on other words, the the left and right side will be 0.05. Okay, so that the total region is going to be 1. So now, but then when you refer to the T table, the region is always counted from the positive line, alright, which means this is the region given by the table. So for the table, we need to read this line as T 0.95, and then the degrees of freedom is going to be n minus 1. So V is n minus 1, and then we know that n is 8, so n minus 1 becomes 7. Right? So when you read the table, it will be 1.860. So now, right, this will be 1.860, and the other line will be the corresponding value, but it will be negative. So I found the T value 1.860. Then the S, okay, so when we refer back to this calculation, I have found S squared. So now, in order to get S, I will just take square root. So I'm going to copy square root of 0.151429 divided by 8. Okay, so now this confidence interval can be counted by referring to the negative sign first, and then you will be getting 5.29 correct to 3 significant figures. And when you are referring to plus, then it will be 5.81. Okay, so this is the confidence interval for the A, right? Now, Raman claims that the population mean height of male giraffes in the region is less than 5.9 meters. So B tests at 2.5 significant level whether this sample provides sufficient evidence to support Raman's claim. So Raman's claims says that the mu, population mean, okay, that means this is mu less than 5.9 meters. That is our H1. So mu less than 5.9. Then for the H naught, it will be mu equals to 5.9. Okay, and then now it is 2.5%. Therefore, it will be 0.025 for the alpha value. Okay, so now, by referring to the graph, okay, we are going to use a T table or T test for this hypothesis testing, because as I mentioned just now, population variance is not given, and then the n is small. That's why we use a t-test. So when t-test, right, to get the critical region, by looking at the H1, which is less than 5.9, it means the region is basically on the left-hand side. Okay, so now this region, the area of the region is 0.025. But then from the T-table, the region is always on the right side. Therefore, I'm going to use green color as the working, as the rough work. Okay, this is not the actual working, it's just a rough work. So now I have to reflect the blue region into the green region. So which means here is 0.025. Alright? And then from the T table, the region is always towards the left hand side. Which means now the region towards the left hand side is basically 0.975. Okay, and then the degrees of freedom is n minus 1, therefore you are getting 7. So this green region, this line, green line is basically T 0.9757. I will get 2.365. But then our original region is the blue region. So by refracting back, okay, you will be getting negative 2.365. Right, so then negative 2.365. Then from here I will write critical value just to make it clear. T7 0.975 is going to be negative 2.365. Okay, so we need to write down the DF first, degrees of freedom first, before the alpha value. So here is going to be 7, 0.975. Alright, so now if followed by the rejection criteria, so I will write reject H0 if T is less than negative 2.365. Okay, so now our calculation, T is x bar minus mu over square root of SD squared over N. So now my x bar, we have counted just now. So the x bar is 5.55, and then this is our s squared. So it becomes 5.55 minus the mu is the mu at the H0. Okay, so at the H0, 5.9. So minus 5.9 over square root, then over 8. So the SD squared just copy from the previous calculation, 0.151429. Then here is negative 2.54. Right? So now look at the graph. Negative 2.54 is basically inside the region. So when inside the region, then we need to reject H0. That is our decision. So now, just write down the decision first. Since T is less than negative 2.365, then we need to reject H0. Okay, so when we reject H0, right, means that we don't support the H0, which means we are supporting the H1. So therefore, there is evidence, sufficient evidence to support Raman's claim, because the H1 is Raman's claim. Okay, so there is sufficient evidence at alpha equals to 0.025 to support Raman's claim. Okay, so this is the full solution of this question. Alright, so let's move on to the next question. Next question is number 6. A teacher at a large college gave a mathematical puzzle to all the students. The median time taken by the random sample of 24 students to complete the puzzle was 18.0 minutes. So now it's regarding the median. The students were then given practice in solving puzzles. 2 weeks later, the students were given another mathematical puzzle of the same type as the first. The times in minutes taken by a random sample of 24 students to complete the puzzle are as follows. So these are the 24 data. Right, so the n is 24. So now, the teacher claims that the practice has not made any difference. No difference at the average time taken to complete the puzzle of this type. Carry out a Wilcoxon sign rank test at 10% significance level to test whether there is sufficient evidence to reject teacher's claim. Alright, so for Wilcoxon sign rank test, our H0 is regarding the population median. Okay, so it's mentioned median is 18.0. Alright, so our H0, you have to write population median is 18.0. Okay, or I write equals to 18.0. Then H1, So the teacher's claims that has not made any difference means that no difference, right? So now the H1 is population median is not equals to 18.0, because if no difference means that it will stay as 18.0 for the median. Okay, so then alpha value is 10%, so 0.1. Right? So for the Wilcoxon size rank test, we need to calculate the difference of the median. Then we need to size rank. After that, we need to count the total positive and total negative values. Right? So now I will draw a table. So let's say this is the x. This is x minus median. Then this will be the size rank, or the ranks. Right? So I will do it for all these 24 values. Means that I will split it into 3 rows. Right? So for each of them, I will be counting x minus median and the size ranks. So x, then x minus median, and then size ranks. After that, x again, x minus median, and then size ranks. Right? So now I will copy all the x here. So I will copy. Okay, so my first x 18.2, then okay, I have 24 data, means that each row has 8 data. Okay, so I need to have 8 columns. 17.5, then 16.4, 15.1, 20.5, 26.5, 19.2, then 23.2. Okay, these are the 8 values from the first row. Then I will continue with the second row and third row before I do all the calculations. So now my second row will be 17.9, 18.8, 25.8, 19.9, 17.7, 16.2, 17.3, 16.6, and then the third row is going to be 17.1. So I just rewrite all the x values. Okay, so 20.3, third, then 12.6, 16.0, and then 21.4, 22.7, and 18.4. Okay, so now after you have copied all this data, then you have to calculate x minus median. So now remember, our median is 18. So it means that all these values must be subtracted by 18. Okay, so now when you minus 18, first value is 0.2, second is negative 0.5, then negative 1.6, negative 2.9, 2.5, 8.5, 1.2, 5.2. So for 17.9, you minus 18, it will be negative 0.1. Then 0.8, after that 7.8, 1.9, negative 0.3, 16.2 minus 18 will be negative 1.8. Then the next is negative 0.7, and the last one is negative 1.4. Okay, 16.6 minus 18. And same for the third row. I mean the third set of x values. 17.1 minus 18, negative 0.9, then 2.1, 2.3, negative 5.4, negative 2, 3.4, 4.7, 0.4. Okay, so now for the side rank, so all this x minus median is basically x minus 18. Right, just for information, x minus 18. Alright, so I think I need to rewrite because you can't see. Okay, so for the side ranks, so this will be the important part that I will use a red color. Okay, now you have to rank all these the differences. So we will start with the smallest number. So basically the smallest difference is here, negative 0.1. Therefore, this becomes minus 1. Okay, then for your information, because the difference is negative, therefore when you write out the sign rank test, because of the sign, right? So when it is minus for the negative value for the differences, then you have to put a negative. Now, after 0.1, it will be 0.2. So this is positive, then I will just write 2. Okay, so these are the sign ranks. Then the next value is negative 0.3. Then this is my negative 3. Then followed by 0.4. This is my rank number 4. Then negative 0.5. Side rank number negative 5. Then my number 6 is when the difference is negative 0.7. So this is my minus 6. The rank number 7 is 0.8. Right, so this is positive 7. Then the next value is negative 0.9. The rank is negative 8. The side rank is negative 8. Then the next one is 1.2. Right, so here is positive 9. After that, 1.4, I will get negative 10 for the side rank. And then followed by negative 1.6, so I'll get negative 11 side rank. Then now, after negative 1.6, the next difference is negative 1.8, which is negative 12 for the side rank. Then negative 1.8 followed by 1.9. This is 13. So after 1.9, the difference goes to negative 2. So here this is my negative 14. Then after negative 2, it will be 2.1. This is rank 15. Then followed by 2.3, rank 16. So now my rank 17 goes to 2.5. Then rank 18, it will be negative 2.9. That means this is side rank negative 18. Right. So then next is 3.4. Then here is 19. After 3.4, the next value is 4.7. So this is side rank 20. And then, okay, after 4.7, then it is followed by 5.2. So this is side rank 21. My next value after 5.2 is negative 5.4. This is side rank negative 22. Then now left only two values, 7.8 and 8.5. So 7.8 is 23. 8.5 will be 24. Okay, so all these are the side ranks. So now, next step is to calculate the total positive side ranks and also total negative side ranks. So for P is referring to plus. So now my P is going to be summation for all the plus side ranks. So now let me leave a space here. So here for the plus sign, the P is going to be 2. Here is my 2, 17, 24, 9, 21, and so on. Alright, so it's going to be 2 plus 17 plus 24 plus 21. Then for the second red row, it will be 7, 23, 13, So 7, 23 plus 13. And then the last red row, it will be 15, 16, 19, 24. So plus 15 plus 16 plus 19 plus 20 plus 4. The total here is 190. Okay, so done for the plus sign. Now we do it for minus sign. That is represented by Q. So the first one is minus 5, then next negative 11, negative 18. So negative 5. Oh, we don't write negative because it's already mentioned negative over here. So we will just take the value, the absolute value. So 5 plus 11 plus 18. Okay, that's all for the negative sign rank. Then the next row, 1, 3, 12, 6, 10. So the last row, the last red row, it will be 8, 22, 14. So then the total is going to be 110. Okay, so now we have found two values, 1 plus, 1 minus. So then our t is the smaller value. Okay, smaller value of P and Q. That means obviously the Q value is smaller. Therefore, I will take 110 as our t. Okay, so now before you proceed, okay, so you have to be alert that your n is 24. Alright, so when you are conducting Wilcoxon sign rank test and the n is greater than 20, you need to use normal approximation, right? So now from here I will write n equals to 24, which is greater than 20. Okay, therefore normal approximation. So instead of solving by using Wilcoxon sign rank test, so now we have to change to normal approximation. Okay, so for normal approximation, your mean is 1 over 4 times n bracket n plus 1. So now our n is 24. It becomes 1 over 4 multiplied by 24, multiplied by 24 plus 1 means 25. And then you will get 150. Okay, then for the variance, it is counted using this formula, 1 over 24 times n plus 1, and then times by 2n plus 1. Then here is going to be 1 over 24. The n is 24. So n plus 1 becomes 25. 2n plus 1. So 2 times 24 is 48. So 48 plus 1, 49. Okay, and then you will get 1225. So once you have found the mean and variance, okay, so I will write the normal distribution. Okay, or before that, or you can just write the normal distribution first. T is normally distributed with mean 150, and then the variance is 1225. Alright, so now we need to compare the T with the mean. So now your T is 110. Okay, so you write, since T is 110, which is less than the mean, because the mean is 150. Therefore, now your T will be 110 plus 0.5, because this is normal approximation. So now becomes 110.5. So we are going to use T as 110.5 for this calculation. So since the T is normally distributed, means now we need to standardize the T. So it becomes 110.5 is a T value minus the mean 150 over the variance is 1225. So we always over standard deviation. So square root of 1225. Alright. So now here you will get negative 1.129. Now, before we write down the conclusion, we need to draw the region first. Alright. So now, from here, our critical value will be two parts, right? So it's mentioned your alpha is, let's check what is your alpha first. Your alpha is 0.1. Why is it two parts, two-tailed test? Because your H1 is not equal sign. So it means that now I know that these two left and right side total is 0.1, which means each part is 0.05. And we are using the Z test, therefore the region is going to be 0.95 over here. And then by using the table, you will get 1.645 for the critical value. Alright, so now from here I will write critical value. Actually, we should do this first before the calculation. It's okay? So Z 0.95. Then this is going to be plus minus 1.645. So which means I will write my rejection region is going to be, I should say my rejection criteria. So reject H naught if the calculated Z, okay, more than 1.645 or less than negative 1.645. Or probably you can write modulus of the Z is greater than 1.645. Okay, so now from here I get negative 1.129. So negative 1.129 is basically outside the region when you look at the graph. Therefore, our decision is going to be accept H naught. Alright, so you write since modulus of the Z is less than 1.645, therefore accept H naught. Okay, so for your conclusion, please refer back to the question. So I want to test whether there is sufficient evidence to reject the teacher's claim. Right? So then from here, from the decision, it is accept H naught. So when accept H naught means that the H naught is true. Okay, H naught is true. So when H naught is true, then you go back to the claims, the teacher's claim. No difference. Alright? Therefore, there is insufficient evidence to reject the teacher's claim. Right? Because we accept H naught means that the mean still same as 18.0. Alright? So you will say there is insufficient evidence at alpha equals to 0.1 to reject the teacher's claim. Okay? Right? So that's all for the solution of this paper. Alright? So again, thank you for watching my video. So kindly subscribe to my channel and stay tuned for more upcoming videos. Thank you. Bye.